Let's take any Hasse diagram. Let's take any Poset. Uh, Let me draw any random Hasse diagram and look at more properties of it. Or let's deep dive into the Hasse diagram and other things related to Poset. I'm just drawing it randomly. Let's name them. Now look at this Hasse diagram now. So A, B, G, H, I, all of these are minimal elements because there is no element that is related to A. You cannot find any element that is related to A or that is related to B. So these are minimal elements. Similarly, E, M, and N, they are maximal elements because there is no upward path from E. There is no upward path from M. There is no upward path from N. Means that there are no elements that E is related to. So if anything, the other elements are related to A, but E can related to E, but E cannot be related to any other element. Similarly, A can be related to M, C is related to M, D is related to M, L is related to M, F is related to M, but M is not related to any other element, as and same is the case for N. So these are maximal elements. This is something that we have seen in the last video. In this video, we will look at things called as upper bound and lower bound. For example, if you take just a set of some elements, let's say you take C and F and K, if you take these three together as one set of elements, just C, F, and K, then some of the elements or some of the nodes are upper bound to the set C, F, and K. So I'm talking about this set C, F, and K. Let's say this is my set S. S is equal to C, F, and K. So if you look at M, then C is related to M, F is related to M, K is related to M. So in the upper bound of S, you will find M. Okay, what about D? D is not related to K, so it is not in the upper bound of S. C and F is related to D, but K is not related to D. So this D is not a upper bound to this set. Okay, so upper bound of any set S. This S is a subset of your partially ordered set. My partially ordered set contains all these elements, and C, F, and K is a subset to that. And to any subsets of your partially ordered set, there is a upper bound to it. There is a lower bound to it. The upper bound is all those elements to which all the elements of the set is related to. Okay, so for upper bound of S right now is M and nothing else. So upper bound of S is only M, because if you look at L, okay, K is related to L, but F is not related to L, and C is not related to L. If you had any more edge going upward from M, let's say this is O, this is P. Let's say these are the two edges, these are the two nodes A, O and P coming from the M. So from in the upward direction to M, then your upper bound of S will contain O and P also. O and P also. Now if we talk about lower bound of S, this is upper bound of S. What is the lower bound of S? So what lower bound means that all those nodes will come in the lower bound set of S, all those nodes will come in the lower bound of S if these elements are related to each and every element in the set S. So if there is no such element, because H is related to K, but H is not related to F. There is no upward path from H to F. There is no upward path from G to K or G to C, but G is related to F. Similarly, B is related to C, but B is not related to F or K. A is related to C, but A is not related to F or K. So there is no element that satisfies or that qualifies to be in this set, lower bound of S. So this is equal to 5. This is equal to 5. So to get the upper bound, what did we do? We look at the first instance, means we go from C, one level above from C, you get D, but then D is not, but then D, K is not related to D. Okay, so it means what? It means what? It means now you will go two level above D. So two level above D in this direction, K will not be related to E. So you go here. Now this is M. Now this M is related to every element of the set S. So from M, whatever upward movement is there, whatever upward path, whatever nodes that come in the upward path from M, those all will be in the upper bound. So M is the first element that you got in this manner, right? And then from M, whatever comes in the upward direction, all of those nodes will be a part of upper bound, because for all those elements, this property holds that every element of the set is related to those elements. Similarly, in case of lower bound, what do you see? Look one step down, and then you check if this is related to every element in the set or not. Similarly, from F you go to one step down and see if it is related to every element or not. Similarly, from K you go to one step down and you see if this element is related to every element or not. If you find one of them, if you find, let's say if you find A, let's say you find that A is related to F and K also. Let's say if it was something like this, let's say there was an A from A to F also and A to K also, it means that your lower bound has A. Your lower bound has A. Now whatever nodes this A is connected to, okay, so I'm talking about whatever network is there in the downward direction, whatever network you will find, each and every node will be a part of node. There's two terms, which is join and meet. What is join? Join is in the upward direction, the first node that you get which qualifies for upper bound. In the upward direction, the first node that you get to which all the elements are related to, that is your first join. And then from any join, in the upward direction, whatever nodes come, all of them will be part of upper bound. Similarly, this A is your first meet. So when you are going in the downward direction, the first node that you get which is related to every element of S, that is a meet position. And from that meet position, if you go in the downward direction, all the nodes here in this network, all the nodes will be part of lower bound. When you are trying to get the upper bound, first you will get to a point of join, and then every other node in your upper bound is in the upward path from this join, right? So we call this as the least upper bound. In this case, you find a least upper bound. Actually, least upper bound may or may not exist, meaning to say that maybe there are more than one joining point. There are more than one joining point, and if there are more than one joining point, then it is not a least upper bound. If there is more than one joining point, then then you are not having a unique join point. If you don't have a unique join point, then you don't have a least upper bound. So what is least upper bound is that in your upper bound, find the element that is the least element. You don't get the least element. I have not talked about least element, right? So I have talked about maximal, minimal, but not the least and the greatest element. In the next video, we will see least element and greatest element, and then we will come back to this concept of upper bound, lower bound, just to define least upper bound if it exists and greatest lower bound if it exists. Thank you very much.